Hi, welcome back to my class in Analytic Geometry. For today, we will apply the distance formula to solving problems, and we will solve problems that involve midpoint of a line segment through two endpoints. And those of you who missed the first few lessons in Analytic Geometry, just search for my videos, Art Teaches Analytic Geometry. Lesson 1, Distance Formula. And Art Teaches Analytic Geometry, Lesson 2, Midpoint. For our first example, consider the following problem. Find the distance between -2, -5, and the midpoint of the line segment joining 2, -3, and -4, 5. The given in this problem are the endpoints of the line segment. The endpoints are the points 2, -3, and -4, 5. And the solution of this problem will take two steps. First step, you have to find the midpoint of the line segment, the point halfway between the points 2, -3, and -4, 5. After we obtain the midpoint of the line segment, we get the distance between the first point given, -2, -5, and the midpoint of the line segment through these points. We let P1 be the first point given with coordinates -2, -5. We let P2 be the first endpoint of the line segment with coordinates 2, -3. And we let P3 be the second endpoint of the line segment with the second point has coordinates -4, 5. And we let P4 be the midpoint of the line segment with endpoints P2 and P3. And these endpoints have these coordinates. Since the coordinates of the midpoint are unknown, we represent the coordinates of the midpoint P4 by X and Y. First, we will get the midpoint, the coordinates x, y of the midpoint P4 of the line segment through P2 and P3. And then we will get the distance between P1 and P4. First, we plot these points in the Cartesian plane, where we write y in the vertical axis, we write x in the horizontal axis. At the intersection of the axes, we write the point 0 or the origin. We start with the point P2, coordinates 2, -3. That means you count 2 units to the right in the positive x-axis from the origin. And from there you count 3 units downward. So this is the point P2. Abscissa is 2 units, 2 units from the origin, 1, 2. And from this point, you count 3 units downward, 1, 2, 3. And you get the point P2. The second endpoint of the line segment has coordinates -4, 5. That means you count 4 units to the left from the origin. And from there, you count 5 units upward in the positive y-axis. So from the origin, we count 4 units to the left, 1, 2, 3, 4. From this point, we count 5 units upward. 1, 2, 3, 4, 5. And we get the point P3. And we connect these points P2 and P3 to construct the line segment with endpoints P2 and P3. And we will get the midpoint of this line segment through points P2 and P3. We denoted the coordinates of the midpoint by x and y. And we will get the coordinates of this point P4. Now the given first point P1 has coordinates -2, -5. This means you count 2 units to the left from the origin of to the left, 2 units from the origin going to the left of the negative x-axis, and from there you count 5 units downward. We count 2 units from the origin, 2 units to the left, 1, 2. From this point, we count 5 units downward. 1, 2, 3, 4, and 5. And this is the point P1. Now we find the coordinates of the midpoint of this line segment through points P2 and P3. And we start with the abscissa x. The abscissa of the midpoint is given by the sum of the abscissas of the endpoints, and the sum is divided by 2. Hence, the abscissa x of the midpoint is equal to x1 plus x2 divided by 2, where x1 and x2 are the abscissas of the endpoints of the line segment. And we take P2 as the first point with coordinates x1, y1. We take P3 as the second endpoint of the line segment with coordinates x2, y2. Hence, the abscissa of the midpoint equals x1, x1 is 2, plus x2, abscissa of the second endpoint, -4. Because x2 is negative, we write -4 in open close parentheses. And the sum is divided by 2. And we get positive times negative is -4. 2 minus 4 is -2. Divided by 2 is -1. The abscissa of the midpoint P4 of the line segment is -1. Now we find the ordinate, the second coordinate of the midpoint of the line segment through P2 and P3. Y is equal to the sum of the ordinates of the endpoints of the line segment. Y1 is the ordinate of the first endpoint. Y1 equals -3. -3 plus Y2. Y2 is the ordinate of the second endpoint of the line segment, 5. And the sum is divided by 2 equals -3 plus 5 is 2, divided by 2 is 1. Hence, the ordinate y of the midpoint of the line segment through P2 and P3 is +1. Thus, we write P4, the midpoint has coordinates x is -1 and y is +1. And we plot the point, the midpoint. This is a point on the line segment through the points P2 and P3, and is halfway between P2 and P3. You count 1 unit to the left, and from there you count 1 unit upward. From the origin, we count 1 unit to the left in the negative x-axis is -1. And from here, we count 1 unit upward, and we get this point. This point on the line, and that is the point P4, the midpoint of the line segment. Now we find the distance of P1 between P1 and the midpoint P4 of the line segment. We construct this line, and we denote the distance of between P1 and the midpoint P4 by small d. And we will now find the distance d between the point P1 and the midpoint P4 of the line segment through P2 and P3 by distance formula. D is the distance between the point P1 with coordinates -2 and -5 and the point P4, the midpoint of the line segment with endpoints P2 and P3. And we found the coordinates of the midpoint P4 as -1 and +1. The distance D is the distance between the points P1 and P4, where P4 is the midpoint of the line segment through P2 and P3 with coordinates -1 and +1. And the point P1 is the given first point -2, -5. By distance formula, the distance between these 2 points is given by the principal root of the square of the difference of the abscissas of these 2 points, denoted by x2 minus x1, plus the square of the difference of the ordinates of these 2 points P1 and P4, denoted by y2 minus y1. We take P1 as the first point and P4 as the second point. If P4 is the second point, we write first the abscissa of P4. 1 minus the abscissa of P1, -2. Since the abscissa of P1 is -2, we write it in quantity in open close parentheses and square, plus the ordinate of the second point P4, +1, the abscissa x2 of the second point P4 is -1. So we write here -1. -1 is the abscissa of our second point P4 minus the abscissa of the first point P1, -2. We have -1 minus -2 squared, plus the ordinate of our second point P4, +1, minus the ordinate of the first point P1, -5. Again, because the ordinate y1 of the first point is negative, we write -5 in open close parentheses minus -5 squared. And we simplify the expression inside the radical sign, or we simplify the radical, and we get D, the distance between P1 and the midpoint, is equal to the root of -1, negative and negative is positive, 2 to the power 2 plus 1, negative and negative is positive 5 to the power 2. To simplify further, we get the root -1 plus 2 is 1 square, plus 1 plus 5 is 6 square. And we simplify the expression inside the radical sign. Square of 1 is 1, plus the square of 6 is 36. And therefore D is equal to the principal root or the positive root of 37. And we do not know the units of the distance, so we simply write the distance between P1 and the midpoint P4 of the line segment through the endpoints P2 and P3 is equal to the positive root of 37 units. For our example 2, consider the following problem. Find x such that the distance between this point with coordinates x3, the abscissa x of this point is the one we want to find in this problem. And the second point, negative 3, 5 is 7. We write the given. We let P1 with coordinates x1, y1 be the first point, x3. And the second point with coordinates negative 3, 5 be the second point, P2 with coordinates x2, y2. And this point is the second point given, negative 3, 5. 7 is the distance between these 2 points. We write D equals the distance between P1 and P2, and it is equal to 7. Now we apply the distance formula. By distance formula, the distance D between these 2 points P1 and P2 is given by the principal root of the square of the difference between the abscissas of these 2 points. We start with x2 minus x1 plus the square of the difference between the ordinates of this and these 2 points, y2 minus y1. D equals the principal root. Our x2 is negative 3 minus x1. Our x1 is x to the power 2 plus y2. The ordinate of the second point is 5 minus y1. The ordinate of the first point is 3. And we square it. Our distance D is given. We can now replace D with 7. The distance between the points P1 and P2. Or we simplify the expression inside. 7 equals the root of, here we can factor out negative 1 to simplify this expression. We factor out negative 3 divided by negative is positive 3. Negative x divided by negative is positive x to the power 2. You may write 3 plus x as x plus 2 since addition is commutative. Plus 5 minus 3 is 2 to the power 2. From this equation, we will solve for the value of x. And we first remove the radical sign from the right by taking the square of both sides. We take the square of 7 and we take the square of the right side. The square of 7 is 49. And by property of radical, the square of the square root of this expression is simply the expression inside the radical sign, or the square of this, the square of a square root of x is simply x. The square of the square root of x simplifies to x by property of radical. So the right hand side simplifies to just the radical, the expression inside the radical, which is this. And we simplify that by property of exponent, is square of negative is positive, multiplied by square of 3 plus x, or square of x plus 3. Square of x plus 3 plus the square of 2 is 4. From this equation, we solve for the value of x. We transpose positive 4 to the other side, and from this side we get the square of x plus 3. The square of x plus 3 equals 49. And positive 4 transposed to the other side, you get negative 4. We have x plus 3 to the power 2 equals 45. Or 45 is equal to 9 multiplied by 5. X plus 3 square equals 9 multiplied by 5. Now we want to remove the exponent of x plus 3 because we are solving for x, and x is inside the quantity. So we remove the exponent of x by getting the root of both sides. Extract the root of the left and the right side by property of radical. You have the root of the square of x is simply x. That's say by property of radical. So the left side simplifies to x plus 3. And the right side, by property of radical, the root of AB is equal to the root of A times the root of B. One of the properties of radical says the root of the product AB is equal to the product of the root of A and the root of B. So the root of 9 by 5 is equal to the root of 9, 3. And a number has, a positive real number has 2 roots. And we write plus and minus. Root of 9 is 3 times the root of 5. Finally, we transpose 3 to the other side. X equals positive. Transpose to the right becomes negative 3. Plus and minus 3 times the root of 5. So this implies that there are two values of x such that the distance between this point x3 and the point negative 3, 5 is 7. We will now plot the points in the Cartesian plane. We extract the root of 5. You may use your own calculator to check this answer. 3 multiplied by the square root of 5 is 6.71. Hence, the values of x are given by negative 3 plus and minus 6.71. The first value of x is given by negative 3 plus 6.71, which gives us 3.71. The second value of x is given by negative 3 minus 6.71, which gives us negative 9.71. Thus, we have two values of x, which means that there are 2 points x3 whose distance from the point negative 3, 5 is 7. Or there are 2 points with 2 points x3 with the same distance of 7 from the point negative 3, 5. The first point has coordinates x3. And for this point, we take the first value of x, 3.71. 3.71 and 3. And the second point, we coordinates x3. For the second point, we take the second value of x, negative 9.71. Negative 9.71, 3. And we plot these points in the Cartesian plane. In the vertical axis, we write y. In the horizontal axis, we write x. The given point has coordinates negative 3, 5. That means you count 3 units to the left, and from there you count 5 units upward. We approximate negative 3 units from the origin going to the left, and 5 units upward. 5 units from the origin. This is the point negative 3, 5. The first point we find with distance of 7 from this point negative 3, 5, negative 3, positive 5 is the point 3.71 and 3, approximate 3.71. From 0 you count 3.71 units going to the positive x-axis, and from this point you count 3 units upward. We approximate. This is positive 3.71. And this is 3. This is the first point, 3.71, 3. The distance of this point from this point negative 3, 5 is 7 units, which we denote by small d. The other point has coordinates, the other point with the same distance of 7 from the point negative 3, 5 has coordinates negative 9.71. So it's here. Count 9.71 units from the origin going to the negative x-axis. We approximate negative 9.71 and 3 units. This is the point negative 9.71 and 3. The distance of this point from negative 3, 5 is also d, 7 units. Thus, there are 2 points xy with the same distance of 7 units from the point negative 3, 5. And these points are 3.713 and negative 9.713. Consider the following problem for our example 3. Find xy find the point with coordinates x and y. If 2, 3, the point 2, 3 is the midpoint between x, y, and negative 4, 5. We have 3 points given here, but one of them is a point whose coordinates are unknown, and we want to find the coordinates of this point x, y. And the midpoint between the point x, y and the point negative 4, 5 is the point 2, negative 3. We let P1 be the point x, y. So in the midpoint formula, this is actually the first point given with coordinates x1, y1. And we let the second point, negative 4, 5, as the point P2. P2 is the point negative 4, 5. In the midpoint formula, this is the second point with coordinates x2 and y2. By midpoint formula, we denote by P as the midpoint between P1 and P2. The coordinates of the midpoint P between P1 and P2 are denoted by x and y. And it is given that the midpoint of the line segment through x, y, and negative 4, 5 has coordinates 2, negative 3. So the midpoint between P1 and P2 with coordinates x3 has coordinates 2, negative 3. 2, positive 2, and negative 3. By midpoint formula, the abscissa x of the midpoint is given by the sum of the abscissas denoted by x1 and x2 divide by 2. The abscissa x of the midpoint is the sum of the abscissas of the endpoints of the line segment divided by 2. And we substitute the given. Our x1 is x, the abscissa of the point we want to find. x1 is x, plus x2 is negative 4. Because x2 is negative 4, we write negative 4 in open close parentheses. Divide by 2. And we are given that the abscissa of the midpoint between P1 and P2 is 2. So x plus negative 4 divided by 2 is 2. And from this equation, we solve for x. Multiply both sides by 2 or cross multiply 2 by 2. From the left, we get x positive times negative 4 is negative 4 equals multiply 2 by 2, 4. Therefore, x equals negative 4 transpose to the right, to the other side. From the other side, we have 4. Negative 4 to the other side is plus 4. Therefore, x is 8. The abscissa of the point we want to find is 8. Again, by midpoint formula, the ordinate y of the midpoint P between 2 points is given by the sum of the ordinates of the endpoints of the line segment, y1 plus y2 divide by 2. Our first endpoint has coordinate y1 and y1 is equal to y plus y2. The ordinate of our second endpoint y2 is equal to 5. And the sum is divided by 2. And we are given that the ordinate of the midpoint P between P1 and P2 is negative 3. So y is negative 3. Again, from this equation, we solve for y. It is now a linear equation in one variable y. We multiply 2 by negative 3. From the left, we have y plus 5. Y plus 5 equals 2 by negative 3 is negative 6. And finally, we transpose 5, positive 5 to the other side. From the right-hand side, we have negative 6. 5 transposed to the right, negative 5. Therefore, y equals negative 11. This is the ordinate of the point xy that we want. Hence, the coordinates of the unknown point xy denoted by xy are 8. 8 is x and y ordinate is negative 11. And the midpoint between xy 8, negative 11 and the point negative 4, 5 is the point 2, negative 3. We will now construct the graph that will show these two endpoints of the line segment and the midpoint 2, negative 3. We now draw the graph to show that 2, negative 3 is the midpoint of the line segment through the points xy and negative 4, 5. We have found the coordinates of one of the endpoints xy, and we have shown that the point xy has coordinates 8, negative 11. We construct that point in the Cartesian plane where we write y in the vertical axis and x in the horizontal axis, and we write the origin at the intersection of the two axes. In this graph, I use a 2-unit interval, so this is 2 units from the origin, 2, 4, 6, 8. And from this point, we count 11 units downward. I also use 2-unit intervals in the vertical axis. Again, for the point xy with coordinates 8, negative 11. Count 8 units from the origin to the right, to the positive x-axis. We have 0, 2, 4, 6, 8. From 8, count 11 units downward. And we get the points with coordinate 8, negative 11. The point whose coordinates are unknown in the given problem. The second endpoint of the line segment has coordinates negative 4, 5. This means you count 4 units from the origin to the left of the x-axis, and from there you count 5 units upward. From the origin, we count 2 units, 2, 4, and from this point we count 5 units upward, 2, 4, and 1 unit, 5. This is the point negative 4, 5. We construct the line segment through this point negative 4, 5, and the point 8, negative 11. Now, this point 2, 3 is the midpoint of this line segment with these endpoints, negative 4, 5, and 8, minus 11. Hence, when you plot this point 2, negative 3, the point must lie on the line. This means that you count 2 units from the origin to the right of the x-axis, and from there you count 3 units downward. From the origin we count 2 units, this is 2, and from this point we count 3 units downward. And you will see that the point lies on the line segment through these endpoints. And this point with coordinates 2, -3 is the midpoint of this line segment, which means that this is halfway between this point and this point, which means that the distance of this point from this endpoint is the same as the distance of this point from this endpoint. We will take more examples on the application of distance and midpoint formulas. If you have questions about today's examples, you ask your questions in the comments below. And don't forget to subscribe to my YouTube channel, Art Calison. Thank you.